So today we will look at some examples, the types of damping we have. So first there is three kinds of or the types of damping. First we have the light damping. Second one is the medium kind of damping, like this less. We have heavy damping, and the last one which is the massive kind of damping, that is the critical damping. So these are the three types of damping that we have. So first so in the previous video we looked at that what is damping, what damping is actually. So it was the reduction of the energy from the system, and in the meantime, and as the energy decreases, so does the amplitude. And I also say that we could also do this using time dilation. Not only dilation, like time reduction. We'll look at this when we go deeper into the types. So first we have the light damping. So this one is what we have, and if we damp this one, if we do light damping, what we get is this. The amplitude is decreasing and it keeps on decreasing, and it ends a little earlier because, for instance, as I said, let me give the same example. Like you were in a swing, so before you didn't consider the air resistance, but if you consider it now, even before, like when we complete the second, or even before completing, considering the resistance, the oscillation, the energy will keep decreasing, and the oscillation that we get, the time that the oscillation we take will also reduce, because we don't have that energy to complete that same arc, to cover the same arc, right? So that's this. So the difference between one cycle and the another cycle is very less. And let's continue to the second one, which is the heavy damping. We also can name this over damping, and it has more damping effect, or we can say like the energy reducing effect or stopping effect. So the difference between the amplitude or the energy reduction between each cycle is more. So if you look at it, so this is the oscillation we had before. So now what happens is the energy in each successive, the amplitude in each successive cycle, it's not a complete so before we took, like for instance, let's say this is 2 seconds and this is 4 seconds. We're looking at this. So this is 2 plus 1, so it's 3. So for one cycle we took 3 seconds, but we for resistance, for instance, the resistance is more, or the resistive force which we give is more, so the energy is decreasing, plus the time that we take for one complete oscillation is also more. So as I said, as a definition I gave, like it's a production of it's my own definition. It's the process of reducing energy, transfer of energy using time relation. So time can also come into play here, and reason why it stretches is that because in the end point appear, why the end points, like this is the end point, why it appears later. So then the reason is here we dilate the time to decrease the force. Like we learned impulse that not only the force, you can also for instance, if you slap someone very slowly, he might not be affected as same as before. So you can also increase the time to reduce the force in a way. So that's, you're decreasing the impulse, and using that you can also reduce the uh, energy, or the or do the damping effect. So I hope you get the point. And last we have is that, so yeah, so for example, like you punch with 20 newton in 0.2 seconds, and you punch someone in the same force, but for 8 seconds. So the bone can break if you like do the same thing, in the short time. But you can give the same force, but by dilating the time, uh, nothing happens to you. So you get the point. So you can either reduce the force, or you can just dilate the time. So either way you can reduce the effect and thus damp it more. Lastly, we have critical damping. So it has the highest effect. For instance, and in here the time should take less. Like you are swinging here, from here to there. So you are standing here, and you're, for instance, there's a small kid, and suddenly you see there is a I mean I mean suppose you are here, and suddenly you see a tree fell. So you must stop her like immediately. So you just stop it, the oscillation instantly. Like, so very, like, you should provide a strong resistive force. So what happens is that difference between the cycle is the highest, between the difference between cycles, yeah, between the both cycle is highest. And in fact, sometimes it doesn't even reach the next cycle. As I said, that the energy is dissipated in the shortest possible time. So for instance, also in bulletproof jackets, what happens is the bullet is almost instantly stopped. So something similar to that, you do it really, like, the damping effect is the highest, the most effective in critical damping, and the time taken is less. So it can be whether more or less depending on the type of damping we do. So that's that, and we will look at resonance in the next video. So we'll keep it up to this.